Well, hello, Team C++. I am back with a new video, and today we are going to talk about C++ basics. We're going to talk about variables and assignment operations and arithmetic and logic operations. We are going to talk about input-output operations. We're going to talk about expressions. We're going to talk about flow of control, and we're also going to talk about the program style. Now let's start with variables. What is a variable? Now before I do anything, let's just talk about a scenario here. Imagine that I want to collect some money to buy something for a class. So let's say I have 5 students and I want to collect, let's say, 3.75, let's just make it simple, $3 from each student. So the total number that I'm going to get, the total number of dollars I'm going to get is basically 15. So if I want to do that calculation here, I will just type Cout, and I can come here and say 5 students multiplied by 3 students, and this basically will show me the results. Let me just include using std and line. So this basically will show me that the total will be 15. So let me just run it. Of course, you have to wait for it to compile and get everything done. And here we go, 15. Let's just make it a little bit more interesting. I'm just going to add a message here. 5 student $3 per student, and I'll just put an arrow here. That basically means I will get 15. And here we go, 5 students, $3 per student, I got 15. Let's make it even a little bit more interesting. I'm going to come here and just put the dollar sign. That's not a big deal. That's not the point of what I'm trying to explain here. Now, this scenario here, or this situation that I have here, basically will work if I have 5 students, and if I have, I'm going to collect $3 from each student. Now the question is, what if it's not 5, and what if it's not 3? What if those values change? What if I want to ask the user who's going to use my program to decide how many students there are and how much money that the user want to collect from each student? So as you can see here, those numbers with this program and this style is really not a good choice to make your program a little bit more generic to be able to be used with every single scenario or different scenarios. This basically will work perfectly fine if you only have 5 students and if you only take $3 from each student, which basically could not be the case. So what do we do? How do I make my program more generic, a little bit different than just sticking with $5 and 5 students and $3? Well, the concept that I'm going to be talking about right now is basically what we call variable. Now, variable is I consider it as one of the most important concepts when it comes to programming. You need to know how every programming language handles variables, and most importantly, you need to understand why variables are important. I just explained it here to you. 5 multiplied by 3, this is a case for 5 students, $3 each student. What if that's not the case? What if I have more students or less? What if I collect more money or less? This basically will not work for that case. So here what we can do, I'm going to comment this section, and I'm going to talk about the concept of a variable. What is a variable? Well, a variable basically is a place inside the memory, and we are going to store a value in that space. And every time we want to use that value in that memory location or space, we are not going to call it by the value, you're going to call it by the memory location itself, the name of that memory location, or the name of that memory space. That name is called identifier. So I will reserve a space inside the memory, I'll give it a name, and then every time I want to, and I'm going to assign a value there, I'm going to put a value in that memory, and every time I want to use that space, basically I will only have to call it by its name. So how do we do that? I'm going to show you later on graphically how is that done, but let me just start here. So whenever you want to create a variable in your program, let's say this is a very simple program. I'm trying to calculate how much money can I collect from this group of students. Well, I need to know how many students do I have, and I need to know how much I'm going to be collecting from each student. So those two variables that I need. And then after that, I need to have a place where I can store the value, the final value of collection. So to create a variable, you need to know very, very important two things at the beginning. The number one is you need to know is what is the data type of that variable. And we're going to talk about data type a lot later. But for now, in this example, I'm having 3, 5, and 3. Those are whole numbers. I'm just going to go with whole numbers here to simplify the process. If I am having a problem that I'm trying to solve, and I know that whatever I'm trying to measure or store doesn't accept the decimal point. For example, if I ask you how many fingers do you have, you will tell me I have 5. Oh, sorry, 10. You're not going to tell me I have 3.4 or 3.5. How many cars do you have? I have 1 car, 2 cars. You don't have a half car. That's basically what we mean by integer. So you need to specify what is the data type at the beginning. In this case, my data types are whole numbers, and to store a whole number, we have a data type called integer. And to create an integer, you just type int, and that's it. Right after you define the data type, after that, immediately you have to give it a name. So what I'm going to do, I'm going to say number of students. And this is me creating a variable. Now, remember, integer here is, let me try to increase the font size. Can I do that? Yes, I should be able. So the data type here is integer. The name is number of students. This is what we call the identifier. Now let's create another one, integer, and then I'll say what do I call the other one? Money. M-O-N, money, per student. Okay, let's see here, take that out. And then finally, integer, I'll call this one total. Okay, now, as you can see here, you can call it whatever you want to call it, but there are some rules that I'm going to be talking about when it comes to declaring variables. So here we go. This is me creating 3 different variables. The first one, number of students, money per student, and total. Now, whenever you have multiple variables that share the same data type, what I can do basically, I can do this. I can actually copy this, put it here, and let me just take this one away. Put a comma here, and do the same thing here, and put a comma here. Of course, if I try to run this program right now, it's going to give me a lot of errors because you're not allowed to have 2 variables that share exactly the same name. So I'm just going to comment this section just to let you know that you can actually create multiple variables using different or multiple statements, or you can put them in a single statement as long as they all share the same data type. Now, this is basically how we create variables. Now, I have a space inside the memory that's called number of students. I have another space in the memory called money per student, and I have another place in the memory called total. Now, what are the values that store here? But right now, after I created them, they basically will have a random negative big value, which basically doesn't make any sense. So what we need to do, we need to find a way to assign values to those variables. And we have multiple ways to do that, but I will start with the basic one. Is basically if you come here and just type equal, and I will say, for example, 7 students, and here I will come and say I have, let's say, 5 students. Okay, now I got the total, and I can come here, I can put it in the same line, or I can come here and say total equal, and all we have to do is copy this, put it here, and then use the multiplication operation, and you put it here, and you put the semicolon. Always remember there's a semicolon at the end of each statement. So as you can see here, what's going to happen when the compiler gets to this point, the compiler will say, oh, number of students. How much is number of students? Well, it's 7. How much money per student is 5? So it's going to multiply the 7 by the 5. And this is very important. This is what we call assignment operation. This is assignment operation. This is assignment operation. What do we do whenever you have assignment operation? You go, it's an expression, as you can see here. You go to the right side, and whatever you have on the right side, you assign it to the left side. So 7 is going to be assigned to number of students. 5 is going to be assigned to money per student. And here, I do have an operation here, arithmetic expression, so the compiler will implement and perform this operation, which is basically multiplying the 7 by the 5, and whatever the result is going to be assigned to total. Basically means assigning by total is going to be saved inside total. Now, if I want to show this on the screen, what I have to do, I'll just go ahead and do SWAT. Oh, before I do that, let me just go here and tell you that you also can come here and put equal 7, and you could come here and put equal 5 if you want. This is me directly assigning those variables. The process of creating the variable and assigning value to it directly in the same statement is called initialization. You create the variable and you give it a value at the same statement. So this is initialization process. Now, before I continue, let me just talk about some rules when it comes to choosing the name of the variable. And this is extremely important, and you need to remember this. Number 1, you are only allowed to use alphabet characters, digit characters, and underscore. I'm not using underscore here, but you can actually come here and put underscore, and you put underscore here. That will work. Now you may think about, oh, adding the underscore here makes it a little bit more easier to recognize what it is. Well, even though that's correct, but it's not recommended to do it that way. So that's rule number 1. You are only allowed to use alphabetic characters, you are only allowed to use numbers, and you are only allowed to use underscore. That basically means you cannot use $, you can have multiplication, you cannot use special characters. You are not allowed to use spaces. This is very important to understand. This is not acceptable. And most importantly, you are not allowed to start with a number. Immediately you should get an error, see? So those are the rules. Don't start with a number, use numbers, use alphabetic characters, use underscore. And that's how simple it is. Now, those are the rules, of course. Recommendations, which basically, there are 2 basic recommendations that everybody should follow, and I want you to follow it too. Whenever you create a variable, make sure you give it a name that represents what it is. Because when you look here, number of students, so reading it that way, number of students, you understand that I'm supposed to store a number of students. But if I come here and say integer, and I'll just put, for example, ty87 underscore, you immediately ask yourself, what is this? What does this represent? Basically, there's no way you can tell what does it represent. So that's basically, this is very important to when you create a code. Your code needs to be easy to understand by people who are going to come after you. And one way to do that is basically to make sure that you choose variables with names and identify that represent what they are. So that would be number 1. Number 2, if you find yourself, if you have a variable that contains only one word, just like total here, start always with a lowercase character. Don't go with uppercase characters, just lowercase characters. Now, number 2, if you find yourself having a variable and you have multiple words, use what we call a camel case. Camel case basically means you put them all together with no spaces or underscores, and at the beginning for each word, you start with an uppercase here and an uppercase here, and most importantly, the first word need to start with a lowercase. So you can see here, number of students, uppercase O, uppercase S. Money per student, uppercase P, uppercase S, and money with a lowercase. So those are the rules that you have to follow whenever you create variables. Remember, there are rules and there are recommendations. If you don't follow the rules, you will get errors. If you don't follow the recommendations, you will not get errors, but when you go for a job interview and you just give them a rubbish identifier, that's basically your ticket to go out. Okay, so let's go back here. Let me try to show this on the screen, and I'll just say, and look at what I'm going to do. I'm going to try to show you, how do I get the exact same message here? I'll put a space. There's no question mark here. Student. I'll put a space, and then I'll put money per student. Control C. Let me reduce the font size. And then I need to put a space here, and per student, $. I'll put it here. And then after that, I'll put total. And then after that, and line, semicolon. So let's go back here. Where is it? Here it is. As you can see, let me just push this a little bit further. And let's reduce the font size a little bit. I'm going to increase it in a sec. So look at here. When I'm going to try to show this on the screen, basically, total number of students is going to replace by 7. After that, I will get the word students. After that, I will get the comma in the space, and then money per student, so it's going to be replaced by the 5. And then after that, per student, it's going to show this as it is, and then it's going to show me the total. If I run it, I will get the result. I should be 30. Wait a minute. Yeah, 35. Here we go. So this is, again, a very, very simple implementation for a very simple problem. I'm trying to figure out how much my total, if I'm going to ask every student to donate $5 and I only have 7 students. So this is, again, what do we mean by identifier, and this is basically how it works. One thing we should know, I forgot to mention in a sec, is the rules that you have to follow whenever you create a variable. In addition to what I said, you're not allowed to use keywords. Now you may ask, what is a keyword? Well, let me show you what is a keyword. Integer. I will go with switch. This is not acceptable. Immediately you get an error. Why is it not accepting it? Because switch is what we call a keyword. And a keyword basically has a special meanings whenever you use it. So you are not allowed to use those keywords as variable names. So that's very important to understand. So how many keywords do we have? We have a lot of them. I'm not going to mention them all right now, but with time you'll memorize them. So for example, using is a keyword. Integer is a keyword. Return is a keyword. Do you see what I'm saying here? If I come here and say integer return, immediately I'll get an error. So you're not allowed to use keywords as variable names. Okay, so if I want to summarize what I just said so far, I talked about how do you create variables. I used 2 formats. How do I use variables? How do I assign values to variables? How do we initialize variables? And how do I use variables within a cout command? Now, let's talk about input-output operations. So far, you learned about output operations because I showed you a couple of them. Here it is. This is an output operation. This is an output operation. But we didn't talk about input operations. Well, usually we can get, let me go back, start with output. Your output operation usually are the screen. You see the result on the screen, but that's not the only way to get outputs. You can store the outputs on a file, which basically is something we might talk about later. But for now, our standard output is basically the screen. This is where you're going to see the result. Now, our standard input is basically going to be the keyboard. So how do I ask the user to enter values? For example, if I want the user to decide what is the number of students and what is the number, the money per student, well, the idea here is very simple. Before we decide that I'm going to put 7 here, I'll just put 0, and I'll just put 0. Usually, whenever you create a variable and you don't know exactly what value should be assigned to it, just go with zeros. This is very important to understand. So I'm going to go ahead here and do all of them as zeros. Now, what I can do here, I can use a very special tool, just like the cout, a special tool called cin. And now I can come here and say using std cin and put semicolon. Okay, now let's go ahead and see how do I use cin. Well, first of all, and this is extremely important, whenever you want to perform an operation, a cin operation, an input operation, you need to show a message to the user explaining to the user what he has to do. So what I'm going to do, I'm going to come here and say cout. I'll say enter number of students. I'll put a semicolon here. And look what I'm going to do. I'm going to come here and say cin, and I'm going to put number of students and put a semicolon. So this is me performing an input operations. Now, what do I do here? Basically, you use the cin tool here, use the extraction operation. Look at this. This is very important. This is insertion, this is extraction. There are two different directions. And you put the name of the variable. Of course, I can do the same thing for the number of dollars. Enter dollars collected for each student. And then, again, you use the same variable and you put it here. So what's going to happen here, basically, you're going to ask the user to enter the number of students, and then the computer will just wait for you to do that. And then after that, you're going to ask the user to enter the number of the dollars donated or collected for each student. So let's run it, and let's see how is that going to look like. And look at this. Enter the number of students. I will go with 10. Enter the dollar collected for each student. I will put, for example, 7. And oh, look what just happened. Well, there's an explanation of what just happened here, and I'm going to go ahead and do that. cin dot ignore. Since I have two input operations, I'm going to put 2 of those. So you may ask, what just happened here? Well, here's what's going to happen. This is a little bit advanced. I am so sorry to talk about it right now, but I'm going to have to do that. When I entered 7 for the number of students, after typing 7, what did I do? I pressed enter. Well, guess what? Enter by itself, it's a character. And I did the same thing for cin. So cin by itself, it's another character. The enter that I pressed after I entered the money per student, that's another enter. So those 2 enters were basically assigned to this get character, and I couldn't hold the screen anymore, and then the program was just terminated. So what I need to do, I need to flush what we call a buffer. All these enters that I'm going to press is going to be stored in that buffer. To avoid assigning the buffer to this get character, I need to flush it before I get to that character. So let's go ahead and run it. Let's see if this is going to work. I'll go with 7, and I'll go with 10, and here we go. I do have 70. Press enter. Oops. I think I just need to take 1 out. And yep, let me just try it again. Let's go here. 10, 7, and here we go. And that's basically how it's done. So this is our input operation. Now, I do have 2 input operations. I can get them done within the same line. And let me show you how do I do that. And again, I'm going to comment this section. Let me comment this first. And by the way, yep. Let's go ahead. I'm going to show this message. Enter the number of students, and let me copy this, and I'll put and, where is it? dollar collected for each student. So look at them. I'm going to try to get them done in the same line. I can come here and say CN, and look at this. I'm going to put number of students, and I'm just going to do this same thing here. So what I'm trying to say here is basically, you can see that I got them done using 4 statements. I can get them done using 2 statements, and I get the same results. The only difference is going to be the way it's going to look on the screen. So let me just run it. I'm going to try to reduce the font size. It's way too big. Properties, 36, and yep. So here's what I'm going to do. I'm going to put 10 space 7, and as you can see here, it worked. So the 10 was assigned to the number of students, and the 7 was assigned to the money per student. Now, if I run it again, there's another way I can actually get this job done. If I press 10, enter 7, and I get the same result. So you need to separate the 2 numbers that you're going to enter by a space or by 10. Don't use any other two characters to separate them. What do I mean by that? For example, if I typed 10, comma 8, it's not going to work. Okay, so this is again how we perform a basic input and output operations using the CIN and the COUT. Of course, to be able to use those tools, we said that before, you need to use the IO stream included, and you need to use all these STDs as well. Let me just make sure that I'm not forgetting anything. Okay. Let's see here. What else I would like to talk about in this example? Well, I talked about the input, I talked about the output, and all of them are going to be done using integers. What I'm going to do right now, I'm going to be moving on to talk about data types. And as I'm going to be talking about data types, I'm going to go back to the same example. So we talked about data types. In this case, I said we have integer data type that I'm using here. Well, let's talk about the scenario that I have here. If I ask you how many students are in the class, you're going to give me a whole number. You cannot tell me there's like 3 students and a half. That doesn't work. So whenever you have a case of integers and you know how many integers you have there, and you try to measure something and you know that it doesn't accept the decimal point, you go with integers. We have many different types of integers. I'm not going to go into the details. I'm just going to mention them right now, and then later in the future I'm going to talk. We have short integers, we have long integers, we have unsigned integers, and each one of them basically will define the range of values you can enter in. Now, I am going to try to find, I'm going to create another video about the data types and how do we use them, but I'm going to go with the basics right now. So, in this case, we have integers. Now, the question is, when I'm going to be talking about money per student, what if one of the students decided to give me, let's say, or they decided all to donate, let's say, $3.50? Well, that's possible, that's acceptable, but since I created an integer here, that's not going to be acceptable. Let me show you what's going to happen if that's the case. I'm going to run it. And let's say we have 10 students. And let's say we are going to be donating, or so we're going to collect in 2.5. So $10 multiplied by 2.5, I'm supposed to get what? $25. Look what's going to happen. Of course, that's not acceptable. Why is that not acceptable? Let's run it again. I'm going to put, again, 10 and let's say 2, and that worked. Well, let me try something else. I'm going to put 2 here. And let me run it again. Let's try again. 10 and 2.5. Nope, that didn't work. Okay. I'm going to show you another example about why is it not working. Basically, because I'm trying to assign a number with decimal points to an integer. It's usually acceptable, but what's going to happen, the compiler will ignore the 0.5 and just take the 2. So I'm going to save this work. Before I save this work, let's just go ahead and talk about a different data type. Now, what if I have a variable that accepts the decimal point? Well, if that's the case, you have two options. You can go with float, or you can go with double. So you have two options. Floats and doubles basically means you create a variable that accepts the decimal point. Floats and doubles basically accept values that are too small or really too big. And by too small, I'm talking about, for example, the distance between the cells in your body. That's how small that distance is. You can measure that using the doubles and floats. Or we're talking about how many people live in this world, or how many hairs are in your head if you have hair in your head, not like me. So that's a really big value. So doubles and floats basically will be used to measure really small values or really big values, and either way they accept the decimal point. So I do have an integer, I do have a double, and I can ask the user now to enter values with decimal points, and that will be acceptable. But the problem is the total here is an integer. So for example, if I'm going to multiply an integer by double, I'm supposed to get a double, because the decimal point was acceptable here, so the final result will have the decimal point. So it's really a good idea to come here and create a double as well. But let's just make it simply, we'll go with float. Now you may ask, what's the difference between a float and doubles? Basically, the difference between them is the range of values you can have with double. The range with double goes really wide. Float is a little bit narrow. Again, I am going to show the details of this later on. Now, with that being said, let's try to run the code again. And let's try to enter some values. So I'm going to go 10. And the second value I'll put, for example, I'll put 7.25. Now let's put 35. So I'll see. And look at this. I'm basically going to collect 73.5. Let's run it again. This time I'm going to put some... Let's say nobody want to donate anything. Let's say I will have 10 students, and each one of them is going to basically donate 0.15 cents. All I'm going to be collecting here is $1.50. Let's put a little bit. Let's say each one of them is going to donate just 5 cents. So 10, oh, you know what, 0.00, something like this. I don't know if that's not a money, but let's just put that value. And you can see here, this is the money that I'm going to be collecting from the whole class. So I can see here that I actually can have decimal points in my calculations. And whenever I want to do that, I have two options. I can go with floats, I can go with doubles. When I put double, we usually use double, but even though that's not a smart choice to go with if you know that the range is not that big. So float is better, but I'm just going to go with double right now. Now the question is, as you can see here, where is it? I'm just going to try to show you something a little bit weird. I'm going to go and put 10, and I'm going to put 1 point, something like that, just for the purpose of the calculation. As you can see here, this is the result. So 19.0723. What happened to this 1? Or, let me just run it again. Let me put it in a different way. I'll put 9, and I'll put here 6 point, something like that. And look at the results. 61.863. Now, you can see that the number that I have here has a lot more digits compared to what I have here. Well, basically, there's a format that the compiler will follow, and it's not going to show you everything. So this is the format, the default format. If you want to control this default format, there is a way to do that, and I'm just going to show you that. And of course, there is a whole chapter to talk about that in the future. This is the part where the result is going to be shown on the screen. So if I want to control it, I need to format the output. And to format the output, basically, there are a few lines that I have to put at the beginning. Cout, and then you put dot, set, f, and then you type dot, not comma. You type iOS, colon, fix. Well, of course, I probably would need to come here and type using std colon iOS. Let's see if that's the case. Yep, he liked it right now. You see, every time I want to use something, I have to add it here. So in a lot of cases, you'll find me just using namespace to make it easier for me, but that's not how it's supposed to be done. And then you do the same thing here, iOS colon, and I will say show point, and then cout dot set f, and then I will iOS colon sorry, not R, set F, I forgot, dot cout dot precision, yeah. And then you type, for example, 2. I'll be back in a sec. I need to take a little break, and I'll be back. So I'm back. Let's talk about those 3 lines that I just added here. Fix basically means whenever you let me talk with show point. Show point basically means whenever you have a double variable or float variable, even if there's no numbers behind the decimal point, show the decimal point. Fix basically means the precision that we have here, which is basically specify how many digits you want to see. Fix basically means this number is basically going to be set to the numbers behind the decimal point, not the whole number, including the real number. So let me just run it, and I'll show you what do I mean by that. So let me just put 10 here. I use 10 to make it easier, and then I'll put 7.0. Let's put a lot of zeros, just like that. And here we go. You see, even though there are zeros, I see those 2 zeros. If I take those formats, I'm not going to see those 2 zeros here. Okay, and look at it, there are 2 here. Let me run it again, and I'm going to show you another number, 10. Let's say 7.0 something. I'm going to put 1, 6, and let me put 9 here. So show point basically means always show the decimal point. Precision fix basically means the number 2 that I have, where is it? Here is for the numbers after the decimal point. So I'm going to see 2 of them, and if I run it, you'll see here that I got 71. I was supposed to add another digital. Sorry for that. Let me run it again. And I'll just go 10, 6.196, something like that. Let's just put an 8 here. And here we go. Let me increase the font here. And as you can see here, I got 61.99. How does that happen? Well, basically, multiplying this by this, you get 61.988. And since I said only 2 digits I want to see, which basically was 89, but this 8 was rounded up, so I got 99. Those 3 tools basically are very important whenever you want to have control over how do you want your output to appear in your the final results. So this is basically what formatting about. Now, I talked about integers, I talked about floats, I talked about doubles. We have long doubles, we have long floats, we have short doubles. No, we don't have short doubles. We also have more different data types. The first one is called character, and let's call it, for example, C. And if you have a character, basically you can only store a character inside it. It doesn't matter what type of character. So for example, I can come here and put the character $sign or $sign, yep, semicolon. Now very important, whenever you want to assign a value to a character, you need to put it between single quotation marks. Now this is basically if you assign it this way, but if you ask the user to enter a character, you don't have to put the single quotation marks. That's very important to understand that you're only allowed to assign one character to this character variable. We also have another data type. It's called boolean. Let me just take that out. Boolean, and I will just say, for example, answer. And boolean basically could be true, lowercase t, or it could be false. We use this boolean variable whenever we want to make decisions. So, for example, I will say answer. What is the answer? True or false? Decision. True or false? Yes or no? Up and down. You see what I'm talking about? Binary decisions here. We're going to have a long talk about booleans later. So we have integers to store whole numbers, double and a float to store numbers with decimal points. We have characters to store characters, and boolean to store boolean variables, which is true or false. We also have what we call those are what we call primitive data types. We have what we call non-primitive data types, and non-primitive data types is basically variables or data type that wasn't generated with the programming language itself. It was generated later. For example, we have a data type called string, and I will call it, for example, name, and here I'm going to store my name, for example, Ahmed. Of course, as you can see, he's complaining, so I need to come here and say using std calling string and semicolon, and now that should fix it, and here we go. This is non-primitive data type. We will have a whole chapter and a whole video to talk about that later. I'm just trying to mention them right now so you will have an idea about those data types. So we got the doubles, we have the integers, we got to talk about the data types and how do they work. We talked about the formatting, how do you format your output. And now I'm going to be moving on to talk about a different topic. But what I'm going to do, I'm going to take a break and I'm going to come back to talk about expressions. So don't leave, stay there. Well, let's keep going. Now we're going to talk about expressions. So far we talked about data types. We say we have integer, we have doubles, we have floats, we have characters, and we have the strings as a non-primitive data type. We have boolean. We need to understand something which is very important. You can assign values to different data types as long as you follow certain rules. For example, if I have an integer, I'll just call it x for simplicity, and I assign to x 0.10.01. And if I come here and say cout x and line. So as you can see here, this is double or float if you want to consider it, and I'm trying to assign it to x. So what's going to happen here? Well, let's look. As you can see here, I just got 10. So basically, yes, you can assign a double to an integer or a float to an integer, but again, what's going to happen, the compiler will ignore anything that's behind the decimal point. So I can put 99 like that, and still I will get 10. And let's see here. As you can see here, I got 10. Now, what if I do the opposite? For example, double x, and I'll just put 10 here. Well, that's not going to be a problem. You still can do that. And that will work perfectly fine. So I can assign different values to different data types, but you just need to know how the compiler is going to react to that. Now let's just go ahead and put a character x and try to assign 10 to it. So what's going to happen here? Look what I just had. Nothing. Well, let me put another value. For example, 120. Let's see what's going to happen if I do that. And look what I just got. I got x. Well, let me put 22. That was coincidence, by the way. I got z now. Huh. Does that make any sense? So 120 was x, 120 is z, and if you look at the alphabet character order, x, y, z. You see the difference? So what is that telling me? That's telling me basically every single character has a decimal value, or decimal value that represents what it is. X is basically presented the character X, not the variable here X. X as a character has a value of 120, and Z, for example, 122. Let me just put another value, for example, 96. Let's run it. And I got this, I don't know what it is. Let me put 100. And I got D. So you see here, every single decimal value, character has actually a decimal presentation for it. We're going to have a lot to talk about that later. We see how do we use that in application. So I can do that if I want. Let's see if I do the opposite, integer. And I'll put, let's say, R here. And if I run it, it's not going to show me R, it's going to show me 114, which basically is the decimal value of R. So as you can see here, I can mix and match here, even though this is not recommended, but you still be able to do it. And so you'll see sometimes this could be really helpful to solve problems. Now, what if I have a variable that is a boolean? And we said boolean basically could have the value of true. And I'm just going to put answer here. Now I want you to pay attention to what's going to be printed if I run this code. You got here 1. What if I change this to false? I got 0. So basically, true is presented as 1 and false is presented as 0. Now, what if I come here and just type, for example, 10, something like that? Well, let's run it. And you'll notice I got 1. Well, that's not true. I mean, 10 is not true, so why is it showing me 1? Well, what if I put my name? It's still 1. Okay, so let me just save you a little bit of confusing here. You basically can assign anything to a Boolean variable. It doesn't matter what kind of data. It could be a character, string, float, double, anything. As long as whatever you're trying to assign to answer here is not a 0, is going to be treated as true. The only case is going to be treated as false if you actually a straight 0 assigned to ans. And then if I run it, you see I get 0. Let me put some decimal points here. And run it again. And you get 0. So as long as whatever you have in this side is not 0, is going to be treated as true. Otherwise, it's going to be treated as false. I mean, by otherwise, I mean if it's actually a 0. So this is very, very important to understand whenever you want to assign values to variables, is to understand the relationship and how does the compiler handle this error. Now, C++ deal with this in a very special way. Other programming language will not allow you to do that. For example, if I come here and try to assign 0, or let's say 9, to a Boolean variable, it's going to tell you, nope, you're not allowed to do that. It has to be true or false, which basically makes it a little bit easier. But let's just keep it now true. Okay. Now, let's move on to another topic, which is basically operations. Now, we basically have mainly 5 different operations, and let me just list them here. We have addition, we have subtraction, we have multiplication, we have division, and we have a module operator. So those are the basic. Let me just go back and put this here. Those are the basic arithmetic operations. Well, you know, there was no need to have them in multiple lines. I just put them in a single line. Now you can apply those operations to any data type, primitive data types, integers, doubles, characters, Well, we don't do it with Boolean variables usually, but I'll just talk about numerical values. We can do that. Even with characters, you can do that, but it's not recommended to do that. So again, we know this from the basic math. You add numbers, you subtract numbers, you multiply numbers, you divide numbers, you module. Now, module could be a different for you. Let me just show you an example. What do we mean by modules? If I come here and say cout, well, you know what? Let me just create two numbers. Integer num1 equal 10, integer num2. Let me put 9 here, and you know what? Let me put 10, and let me put. Why do I do that? Let me put 9, and let me put 2 here. I'm going to try to module it. So cout 9 module. Sorry, not 9, num1 module num2. The module operation basically will return the remainder of the division. So when you divide 9 by 2, you will get 4. Let me just put it here. 9 divided by 2 equal, and let me just put a comment. It's basically 4 and 1 divided by 2, 4.5, which basically equal to 4.5. Now, I'm not concerned about 4.5 here. I want to know what is this value here, which is 1. And that's what the module will return. Let me put it in a different way. What if I put, let me put 3 here, and instead of, I'll put 11. So this basically means you will get 3 and 2, and this is going to be 3. So the remainder of the division of 11 divided by 3 is basically 2, and that's basically what's going to be giving here. So let's just put 11 here and put 3 here. Run it, and you'll see that I will get 2. And here we go. That's the module operation. Now, this is, again, very, very straightforward. They're very, very easy, but there's one rule that everybody should be aware of, and I'm going to talk about this rule right now. Now, and let me take this away, and let's keep it simple, as you can see here. Okay. When you apply any of those arithmetic operations into two variables of the same data type, the result will be the same data type. So integer, integer give you integer. Double, double give you double. Float, float give you float. What else do we have? Character, character will give you a character. That's how it works. But again, let's just focus on numerical values that we're going to use here. Now the question is, what if I mix and match between them? Like a double with an integer, or a float with a double, or an integer with a float. Well, if you have a case like that, then the data type result is going to be similar to the was going to be from the data type, the same data type of the one that reserved more space. And if you're concerned about which one of them reserves more space, well, double has the most, float comes next, and integer has the less. So basically, if you have integer and float, the result is going to be float. Integer and double, the result is going to be double. Float and double, the result was going to be double. So what does that mean? For example, integer x, or num1, equal 10. Double, num2, equal, let's say, 12 point, something like that. So if I multiply those together, and let's go ahead, cout num1 multiplied by num2, the result basically is going to be a double, because I got integer and double, and I'm applying an operation between two different data types, so the final data type is going to be a double. Let me run this, and you'll see that the result is basically going to be a double, like as you can see here. Now, why is this important? Well, I will show you an example that a lot of students forget about a lot. Let me go back here and change this to be an integer, and this is going to be 3. And okay, now I'm not trying to multiply them. Let's try to divide them. Now, what do I have here? Before I run it, I have num1, which is an integer, num2 is an integer. So I'm dividing an integer with an integer. So since both of them are the same data type, so the result is going to be what? An integer. And if I run this, or let me just put 5 here and put 2 here to make it simpler. So 5 divided by 2, we know it's supposed to be a 2.5, but just because both of those are integers, the result is just going to be an integer, and that's basically what we call an integer division, which is basically, it's a very, very special case that we have to pay attention to. Now the question is, what if I actually want to have the right results? Well, I want it to be 2.5. Well, there are two scenarios to solve this problem. Number one, you could come here and type a double and convert number 2 to be a double, which basically is not the best option, but let's just go ahead and do that. That will solve the problem. But again, you're basically ignoring a very important factor here, which is memory management. Whenever you create a program, you need to make sure that you choose the right data type for the right variable. So 2, integer is more than enough for 2, but now you're going with double, which basically is going to reserve a lot of space for a very small value, and that's considered as a waste of memory. So if I want to show the result for the purpose of just showing the result without changing the data type, what I can do, I can come here and cast number 2. Cast number 2 basically means change the data type of number 2 at that moment and at that moment only. So if I come here and type double, this is me changing num2 to be treated as double, but it's not double, it's integer. And the reason I'm doing this just for me to be able to get the result as a double. And if I run it, and here you go, 2.5. So casting is basically an option that you have to change the data type of a variable temporary just for a purpose, as you can see here, just to show the result. But right after that, if I go back down here and try to use it, it's just going to act as an integer. So it's just going to be converted to a double at this moment only, and then it's going to go back to be a regular integer. And those are the arithmetic operations. Now, one thing you should know, too, about arithmetic operations is what if I have a mix and match between them? For example, let's create another integer here, and let's just put num3, and let's put 7, for example. Now, the question is, let's take this one away. You know what, let me just keep this here, copy this, put it here. This will be done no casting. And let's start with this. Num1 plus num2 multiplied num3. Now I have a mix and match between those operations. Why are you complaining here? And for the mouse. Overload. Okay, I think I might know the reason. Let me just put a parentheses and see if he's still going to complain about this. Yep, that fixed it. So I got those 3 operations. Now the question is, what will be the result? Am I going to add those 2 numbers and then multiply it by num3, or I'm going to multiply then add the results to 1? Well, the answer here is basically every single operation has its own priority or preference. So whenever you have multiplication, division, subtraction, adding, division, you need to understand which one of them goes first. Usually multiplication and division and modules, they have the highest priority, so they need to be done first, and then adding a subtraction. So in this case, I'm going to be multiplying 2 by 7, which is basically 14, and then it's going to be added to the 5, so I get 19. And here we go, 19. Now, what if I don't want that to happen? Well, basically, I can specify which operation I need it to be done first by putting parentheses around it. So this is basically going to add the 5 to the 2, which is going to be 7. Then 7 is going to be multiplied by 7. That should be 49, I believe. I forgot timetable. Yep, 49. Okay, now let's have another example. What if, let me take this away and this away, what if I have a division here? 1 divided by 2 multiplied by 3. So is it going to divide 1 by 2, 5 by 2, and then multiply by, or they're going to do the multiplication and then the division? Let's give this a try. And you can see here I got 14. So what happened basically here, since the division and multiplication has the same priority, the division is going to be implemented first, and then the result, which is 5 divided by 2, which is going to be 2 multiplied by 7, so I get 14. What if I don't want that to happen? I need to actually put a parenthesis here. So I was going to multiply 2 by 7 first, which is going to be 14. And then I'm going to divide 5 by 14, which is basically going to give me 0. And here we go, 0. So this is very important to understand. Let me take this away. And those are the arithmetic operations. Now, we have what we call shorthand operations. And I'm going to show you those shorthand operations. Let's just go down here. We do have we have a plus equal, we have minus equal, we have multiplication equal, we have the division equal, and we have the module equal. So what, sorry, module, not 5. So what are those operations? Well, I'm just going to show you an example, for example, with the plus equal. So if I come here and say num1 equal num1 plus 10, what does that mean? Again, this is an assignment operation. I have the value. Whenever you have an assignment operation, basically you have a left side and you have a right side. You finish the implementation of the right side, and then whatever the result, you assign it to the left side. So you go to the right side. What do you have? Num1 plus 10. What is num1? Num1 is 5, so it's going to be 5 plus 10, which is 15. The result here is 15. What do I do with 15? I basically assign it to num1. So the value of num1 is going to be changed after this to be 15. Okay, I can rewrite this statement using this shorthand or shortcut operation. I will say num1 plus equal 10. This is equivalent to what you see here. It means update the value of num1 by adding 10 to it. This is more efficient, faster than just going with the tradition way. And that's basically what does this operation means. Let me just check and see if I missed any operations at this point. No. We're going to talk about the plus plus minus minus later, but just for now we are moving good. The last part I'm going to talk about here, which basically in the next video I will get into a little bit more details about this part. It's basically the they call it flow control, and we also going to have to talk about what we call the programming style. Now, programming style, I'm going to talk about it right now so I can get it out of my chest. How to write a program that is easier to read. Now, as I said before, it's all about comments, and you need to add comments. So I explained the concept before in the previous video. Now, one thing that I forgot to mention about variables before I move to the flow control concept, which is basically constants. So what is a constant? Well, a constant is basically a variable that has a value that you cannot change. You see here all the values that I created. I can change those values any way I want to any value that I want. But sometimes we have variables, for example, double pi. Pi. Now we know pi is 3.147, I would like to say. So here we go. This is a variable. I call it pi. Well, let's just put it as a pi for now, and then I'm going to change that. And it has this value. Now, this is a type of variable that I know for sure it will never change. And whenever you have a variable that you know for sure will never change, it's very, very good idea to start by typing the keyword constant, C-O-N-S-T. And now, after you're done with that, it's recommended to keep the pi variable all uppercases, so you can distinguish it from a regular variable, which is usually lowercase characters. So this is pi. If I go down here, for example, and say pi equal something like that, immediately you get an error telling you, well, pi is your expression must be modified value, so modifiable value. So since it's constant, you cannot change it. So that's a good idea. Now, it's recommended to use constants every time you have a program. For example, let's say I have a class and I know the maximum number of students that I can have in this class are 20 students, and I am not allowed to pass that limit. Well, here's what I can do. Constant integer, because I'm talking about number of students, and max underscore student. And then I'll put 20. One thing you should know about constants, you need to initialize it. You don't have any other options. When you create a constant, immediately you have to give it a value. So this is, again, a recommendation that you have to go through. So this is the end of expressions, arithmetic expressions. And the only part left here to talk about is flow control, and I'm going to be talking about that in a sec. Usually, the execution of any C++ program or any other programming language goes from one line to the other, and that's basically how it works. That's what we call the normal flow. So, for example, if you take this program as an example, the program is going to be executed by executing this line and then moving to this line and then moving to this line. That's the normal flow. Now, what do? We basically have tools that we can control the process of the flow of control. And some of those structures that we're going to learn is basically called the selection structures, and some others are called the repeating structures. Now, I'm not going to get into the details because the next two videos are going to be all about repeating structures and selection structures, but I'm just going to go through the basics. Whether it's a repeat structure or selection structure, usually we have what we call a boolean expression that will help you make a decision about what's going to happen next. So let's start basically talking about the selection structure. Let's imagine we have an integer called age, and I'm going to assign the value 10 to the age. In my mind, if you are younger than 10 years old, then you are a kid. If you're not younger than 10 years old, then you're not a kid. So let's put 16. Let's just put it that way. That's the age of the threshold between a kid or not a kid. So let's just do that constant. And what am I going to call integer? And I will say kid age. Now I'll put 16. So anything below 16 is a kid age. So I want to check if, let's say, Adam age makes him a kid or not. So I can come here and say, and look at this, this is very important, if, and I'll just sum here, Adam age, and look what I'm going to do here, below or less than kid age. If that's the case, do something. So I'll go say C8, Adam is a kid. Semicolon. Okay, so let's go ahead and run this. Oh, before I run, let's say here, since Adam is 10 and a kid age is 16 or below, and what I'm doing here, I'm checking, this is what we call a Boolean expression. Boolean expression basically have one variable on one side and another variable on the other side, and there is a comparison operation between them. Well, actually, yeah, let's just keep it for now as less than. So the compiler will evaluate this expression. If it's true, whatever between those curly braces is going to be executed. Otherwise, it's going to be skipped. So let's just run it for now. It says Adam is a kid. And that's right. Let me put 9 here, which basically means Adam is not a kid. But let me just run it. You'll see that the compiler will skip and just go to the press any key or enter to exit. So you see, this is a case where I only care if Adam is a kid. What if I actually care? I want to see a different response if Adam is not a kid. Well, here's what we can do. You put else here, and you open a curly brace, and you close it, and then you copy this, and put it here, and just say Adam is not a kid. And let's run it, and you'll see that your compiler will have a decision to make. Adam is not a kid. So if this expression was true, then this is going to be executed, and whatever inside the else block of code is going to be ignored. If this was false, this is going to be ignored, and this is going to be executed, and this is basically what we call a selection structure. As you can see here, one case, a statement is executed and the other one is ignored. The other case, the other one was ignored and the other one is executed. So that's basically what we mean by selection structure. Now, what's very important here is this Boolean expression here. We do have a lot of tools to talk about here, and we call them comparison tools. Now I'm going to go through them really fast. We have less than, we have greater than, we have less than or equal, we have a greater than or equal, we have equal, and we have not equal. So those are the operations, and we're going to talk about them a lot later in the next video. Now, one thing you should understand, and this is extremely important, and I'm telling you this from experience, I've seen a lot of people get confused between this. And guess what? There are other programming language that has 3 of those. C++, just keep it simple. Double equals comparing to single equal. You need to make sure that you understand the difference between them. Let me just show you what I mean by that. If I put double equal here, what am I doing here? I'm comparing Adam age to kid age, and I'm trying to see if basically they both equal the same, which is basically not the case here, because this one is 19, this one is 16. Now, what if I take one of them out? What is going to happen here? Well, now this is not a Boolean expression anymore. What I'm doing here, I'm taking the value 16 and I'm changing the value of 19 to equal 16. So 16 is going to be assigned to Adam age to equal 19. The compiler would take this as true because the final result of this operation is not 0. It's something happened actually. So that's very important to understand, the difference between equal and a single equal. Again, I'm not going to get into the details because this is going to be a 1-hour video later. Now, we do have what we call nested if statement. We have switch statements. All of those are basically different format of selection structures. We also have a case where I can mix multiple expressions here. For example, I can come here and say and Adam equal kid's age and x equal y, or x is greater than y. So this is what we call a Boolean operation, a logical operation, and the whole thing here is one Boolean expression and one Boolean expression. They are trying to be connected together using the AND logical operation. As I said before, I'm going to talk about the details of each one of those operations. What does it mean, and how do we actually use them? Just to give you an idea, if you have an AND, that basically means this has to be true and this has to be true for the whole thing to be true. We also have an OR operation, which basically means one of them has to be true for the whole thing to be considered as true. Now, let's move on to a repeating structure. Now, repeating structure, from the name, it should tell you that what's going to happen. You're going to ask the compiler to do something for multiple times. Now, we do have 3 main tools to do repeating structures. We have for loop. Let me just comment here. We have for loop, we have a while loop, and we have a do while loop. I'm just going to show you one of them right now, and then we're going to talk about them in a lot of details in the next 2 videos. So let's talk about the while loop. let me just come here and say integer counter equal 1. So I have a variable, I called it counter, and I will say as long as counter is less or equal 10, show me the money. Now, if you know where is this code coming from, which movie, please comment that down. Show me the money, show me the money, show me the money. Now, what I'm saying here, as long as counter is less than 10, then show me this message. Well, counter equal 1, and then I'm going to see this message, and then I'm going to go back here, and counter still equal 1, so that's going to be true again, and I'm going to show this message, and I'm going to end up having what we call infinite loop, a loop that will never end. So what do I need to do? I need to update the counter here. Plus equal, let's say 2. So every statement, counter is going to be increased by 2. So at the beginning, let me put 0 here. At the beginning it was 0, and then it's going to be 2, and then it's going to be 4, and then it's going to be 6, and then it's going to be 8, and then it's going to be 9, and then it's going to leave. So if I run it, you'll see that this is going to be printed for 5 times. Let me show you that. And as you can see here, Adam is a kid, and you got 1, 2, 3, 4, 5, actually 6 times, not 5 times, yeah. Because 0, 2, 4, 6, 8, and 10. So yes, 6 times. This is basically what we mean by repeating structure. Now look at this here. I made the computer repeat this line of code 6 times. Oh, let me just change this to be 1 time, so I'm going to get it to be repeated for 10 times by using 4 lines of code. That's basically what we mean by repeating structure.